So now we will discuss first two important theorems of moment of inertia. One is theorem of perpendicular axis and second one is theorem of parallel axis. What is theorem of perpendicular axis? If you know moment of inertia of any object in two mutually perpendicular directions about two perpendicular axes, suppose one is this and second one is this. So with the help of these two, you can get moment of inertia about an axis which is perpendicular to the both of these axes and passing through their point of intersection. Or you can say कि if you know the moment of inertia of any object about x-axis and y-axis, you can remember fast in this way. I am making three axes, x-axis, y-axis and z-axis. It will give you feel of three dimensions. If you know the moment of inertia about x-axis, you know the moment of inertia of any object about y-axis. You can calculate about z-axis. It should be the sum of previous two moment of inertias. It is the theorem of perpendicular axis. What is the special thing in x-axis, y-axis, z-axis? X-axis and y-axis are two mutually perpendicular axes and z-axis is perpendicular to these both axes and passing through their point of intersection. Only then you can apply this theorem, theorem of perpendicular axis, theorem of perpendicular axis. What is the theorem of parallel axis? If you know the moment of inertia of any object about an axis passing through its center of gravity, you can calculate moment of inertia of that object about any axis which is parallel to this axis. If it is at a distance, you will get by the formula, it is I, and you know the moment of inertia about this axis. I am writing it ICG, moment of inertia about an axis which is passing through center of gravity. So you can calculate moment of inertia about any axis which is parallel to this axis by the formula I is equals to ICG plus m a square plus m a square. In this way you will get the moment of inertia about any axis, but it should be parallel to the axis which is passing through the center of gravity of that object. I will tell you the use, how to use these theorems. First, I am telling you moment of inertia of some objects. See, you have to learn only these 4-5 figures. Moment of inertia first of a ring about an axis passing through its center and perpendicular to plane of ring. It is mr square. Next, moment of inertia of a disk about an axis passing through its center and perpendicular to plane of disk. See, what is difference between a ring and a disk? In a disk, some mass is near to axis of rotation, but in a ring, whole mass is at a big distance from axis of rotation. All are at circumference. That's why, according to the rule sigma mr square, moment of inertia of ring should be greater than moment of inertia of disk. So, for formula for disk is half mr square. Next, same concept we will use for different solid and hollow figures. Moment of inertia of a rod along or about an axis passing through its center and perpendicular to its length is 1/12 m L square, and moment of inertia of a sheet about an axis passing through its center and perpendicular to plane of sheet is 1/12 m A and B are the dimensions, length and width. Next, moment of inertia of hollow sphere about an axis passing through center is hollow sphere 2 by 3. If it is solid sphere, about an axis passing through center is, it is less, it should be less, 2 by 5 mr square. And moment of inertia lastly, of solid cylinder about its own axis You know the axis, I am talking about this axis. Its own axis means this axis. It is solid, then it is half m r square. Like disk, remember, like disk, it is half m r square. Disk is the part of solid sphere, a solid cylinder, so learn in that way. And for hollow, if you take cross section of hollow, you will get a ring. So for hollow cylinder, about its own axis, you will get mr square. So learn these 2 to 4 to 6 and to 8 results, and if you need about any other axis, you can calculate by using that theorem. It means, see, suppose I want to calculate about moment of inertia of rod about an axis passing through one of its end. Suppose I have this rod. I know the moment of inertia about this axis, but my target is now different. In my numerical, I need moment of inertia about this axis, which is parallel to the axis passing through center, perpendicular to the length, but it is passing through its one end. I want to calculate about this. Length of my rod is L and its mass is m. I need moment of inertia about this axis. Rod is rotating about an axis, rod is in like this. Suppose this is axis of rotation, it is rod, it is rotating in this way, means about its one end. How to calculate now? In numerical I need that, so I will go for theorem of parallel axis. I should be ICG plus m. What is distance? This distance should be L by 2. MA square, A means L by 2. I got my result. ICG I know 1 upon 12 ml square. In this, ml square by 4 means 3 ml square by 12 and 1 ml square by 12, 4 ml square by 12 means ml square by 3. So I got this formula. Suppose you want to calculate moment of inertia of a disk. It is a disk. About its diameter. We know that suppose it is a disk. Take any diameter. Distribution of mass is same for any diameter. So moment of inertia about any diameter, it should be same because distribution of mass is same about any diameter. So I choose two perpendicular diameters. If moment of inertia about this diameter is I, for this it should be I. And I know the moment of inertia passing through center and perpendicular to the plane. So I can apply theorem of perpendicular axis. This I plus I should be equal to that moment of inertia which I know, half mr square. So in this way 2I is equals to mr square. So I got the value of I, mr square, half mr square by 4. It means moment of inertia of disk about diameter, we got mr square by 4. So in this way, theorem of parallel axis and theorem of perpendicular axis both are very, very useful. With the help of that, we can calculate so many things. So now we have a complete revision of all the points which we need for motion of system of particles and rigid body. Remember the position of center of mass, velocity of center of mass, acceleration of center of mass, analogues of physical quantities in rotational motion and translatory motion. Remember, law of conservation of angular momentum, very important. Total kinetic energy, don't be forget, it is sum of translatory kinetic energy plus rotational kinetic energy. In rotational motion, if object is in combined motion, total kinetic energy is sum of rotational kinetic energy plus sum of translatory kinetic energy. And remember the motion on an inclined plane. You can get the velocity at bottom by equating the potential energy with total kinetic energy of object if plane is rough. But if they are confusing you and they are giving a smooth plane, don't be confused, it is not a problem of rotational motion. It is a simple problem of translatory motion only. And remember the theorem of perpendicular axis and theorem of parallel axis, and that 8 results. And remember, for same dimensions, for same m and same r, moment of inertia of hollow object should be greater than the moment of inertia of solid object of same shape. Means if we are talking about solid sphere, hollow sphere, m and r are same, then for hollow sphere, moment of inertia should be greater than moment of inertia of solid sphere, because in hollow sphere whole mass is at large distance from axis of rotation, and moment of inertia is all the game of distribution of mass. Similarly, for ring and disk of same dimension, moment of inertia of ring should be greater than the moment of inertia of disk. And moment of inertia of hollow cylinder and solid cylinder about same axis, moment of inertia of hollow cylinder should be greater than moment of inertia of solid cylinder. If these points you are keeping in mind, we are able to solve all problems which they are going to ask in your NEET exams. So now we will discuss 45 numericals maximum from your previous exams, and some new problems are there.